Okay, now let's talk a little bit about DHCP for IPv4. DHCP is Dynamic Host Configuration Protocol, and we're going to talk about it as being a server and how we're going to use it on our routers. Keep in mind that every device that connects to your network has to have a unique IP address. Now, as a network administrator, this could get a little daunting if you have numerous devices with IP addresses on your network. Now, there will be certain devices that you want to have static IP addresses on, meaning that they're not going to change because you're going to need to access them. Let's say network printers. You're going to need to know their IP addresses and they don't need to change so that you can assign those to the different devices that need to have access to your printers. Now, you will have other devices such as your workstations and your mobile devices that do not need a static IP address. The devices may move around your organization. The people may move around your organization and function in different roles. You don't want to have to manually keep up with hundreds of IP addresses. So what we're going to do is we will allow DHCP, again, the Dynamic Host Configuration Protocol, to keep up and assign these IP addresses dynamically. So our DHCP version 4 server, it is scalable and it's going to be the one who assigns your dynamic IP addresses. It is scalable, it's relatively easy to manage. However, if you have a small branch or a SOHO location, your Cisco router can actually be configured to do or to act like your DHCPv4 services without actually having a dedicated server. So this could be a money-saving issue. Your network may be small enough that you don't need to have that additional server. And the Cisco iOS feature set, it's called Easy IP, offers an optional full-feature DHCP server. Now, with our DHCP version 4, it's going to include 3 different addresses, allocation mechanisms to provide flexibility when we go about assigning these IP addresses. Now, keep in mind that it's going to take care of it for you. It's not ones that you have to come up with. You have your manual allocation, and that's the administrator assigns a pre-allocated IPv4 address to the client, and then your DHCP4 communicates only the IPv4 address to the device. So that's manually. You have automatic allocation. That is where your DHCPv4 automatically assigns a static IPv4 address permanently to a device. You're going to select it from a pool of available addresses. There's no lease and the address is permanently assigned to the device. Then you have your dynamic allocation. And what this is going to do is it's basically a lease. So we're going to lease our IPv4 addresses from a pool of addresses for a limited period of time to the device. So our dynamic allocation is the most commonly used DHCP version 4 mechanism, and that's what we're going to talk mostly about. If you'll keep in mind when you go into NetLabs and Live Labs, remember I tell you to set it back, and especially in Live Labs, when you've changed the PC's IP address to obtain, and that's what it's doing, is it's going out there and it's requesting an IPv4 address from the server. It's obtaining one every time it's turned on and comes up to be used. So this IPv4 address that we're going to list from the DHCP server works in this order. Your client communicates with the server. The server then assigns it or leases it the IPv4 address to that client. The client then connects to the network with that leased IP address until the lease expires. The client must contact the server periodically to renew or extend this lease, and the lease mechanism ensures that the clients that move or are powered off don't keep a hold of the IPv4 address that it no longer needs. So once that lease expires, the DHCP server then takes that address and puts it back in its pool of addresses that it can reallocate to another device. Because keep in mind, if you're running on a mobile device and you're on one building in your network, let's say you have multiple campuses and you're in campus A, when you leave campus A and move to campus B, you no longer need campus A's IPv4 address that the server leased to you. You'll request a new one because you've left the premises and then you've rejoined the network but at a different location. So that's kind of how that one works. Now keep in mind that when you're using DHCP that you have a DHCP version 4 message format that's used with all your DHCP version 4 transactions, and these messages are encapsulated within the UDP transport protocol, and the messages are sent from the client and they use the UDP protocol port 68 and their destination port is 67. The DHCP version 4 messages sent from the server to the client use UDP source port of 67 and a destination port of 68. Now your Cisco routers, like I said, can work as your DHCP server. Okay, so depending on which version of the Cisco IOS it's running, it can be the server. And what it's going to do is it's going to assign and manage IPv4 addresses. Okay, so we've got our DHCPv4 server set up on our router, and we're going to assign IPv4 addresses to our clients. Okay, so the first step is excluding IPv4 addresses, and what this means is that the router is functioning as your server, assigns all IPv4 addresses in a DHCP version 4 address pool unless configured to exclude specific addresses. Typically, some of your IPv4 addresses in a pool are assigned to network devices such as your printer, maybe a phone. It just depends on what needed a static address. So these IPv4 addresses should not be assigned to other devices, so we have to exclude those. A single address or a range of addresses can be excluded by specifying the low address and a high address. That gives it a range, so that it will exclude it from being assigned through the DHCP server portion of our router. And here's an example of that. Next, you're going to configure your DHCP pool. You do that by doing IP DHCP pool and give your pool a name. Make it a name that makes sense to you so that you can remember what it is. Okay, then you're going to configure specific tasks for this pool to do. Is it going to be a DNS server? Are you going to define the domain name? Then you're going to define the duration of this lease. How long are you going to lease it for? And then define the net BIOS for that. And here's a good example of all those steps. We've excluded a range of addresses, a particular address, then we created our pool, we told it what the network is, the default router, the DNS server, the domain name, and then we ended it. So those are your basic steps. And one thing to keep in mind with your DHCP service is that it is enabled by default. It's not one that you have to tell it no for, like no shutdown in order to get it to start up. If you do want to disable the service, you have to use the no service DHCP global configuration mode command in order to disable it. And once you've disabled it, to re-enable the DHC server, you have to go in and re-enable that at that point. Now with your DHCP, you can have what's called DHCP Relay. And if you have a very complex network, your enterprise servers are usually located in a server farm. So all your servers are typically together. And these servers may provide DHCP, DNS, they may provide TFTP and FTP services for your entire network. And so your clients are not typically on that network or that same subnet as the servers. So in order to locate your servers and receive services, clients often use what's called broadcast messages. And we've talked about broadcast messages in the past. Now, as a solution to this problem, an administrator can add DHCP servers on all the subnets. But keep in mind, the more things you add to your subnets, the more overhead you have, and you have additional costs financially. You have additional administrative overhead. So it just costs more all around, and it also may slow your traffic down on your system. A better way to do this is to configure your helper address, and this solution enables a router to forward your DHCP broadcast to the DHCP server. It knows where it is, so it's going, hey, send it over here so that we can use it. So when the router forwards the address assignment and parameter request, it's acting as a DHCP relay agent. So it's saying, hey, I've got your information, but we're going to go ahead and move on over here. Now, don't think DHCP is the only service that your router can relay. By default, the IP helper address command forwards the following 8 UDP services. It can do port 37, which is time, port 49, which is TACUS, 53, which is DNS, 67 is DHCP boot TP client, port 68, which is DHCP boot TP server, port 69, which is TFTP, port 137, which is NetBIOS name services, and port 138, which is NetBIOS datagram services. So we can use our syntax checker if you want to practice keying things in correctly. When you're going through your ebook, they do have several really good syntax checkers throughout this unit so that you can make sure that you're getting all the nuances in the correct order. And I highly suggest that you do that. One of the things that you can do, especially if you're in a very small network, is you can create your router as a DHCP client. You go into that interface and you give it the command IP address DHCP. You do a no shutdown, and then that particular interface is assigned an IP address from your DHCP pool. A lot of times this is used with your cable modem, or depending on who you have your service with locally at home or in a small business. It may be coming through your ISP's DSL or cable modem, and typically there you can go in and you can pull up the IP address, you can pull up the software that goes with your provider to see what your information is. You can see what your MAC address is, you can see what IP address you're being assigned. So this is one of the things you can do at home just to see where things stand. And you'll notice that you can also renew your lease typically with the available software. So we've renewed our lease. You may need to troubleshoot, and some of the things you need to look at is you need to make sure that you resolve the address conflicts. You need to verify you actually have physical connectivity. You need to test with a static IPv4 address that you know. You can verify switch port configuration, and you can test from the same subnet or the same VLAN. Because if another one is working, you may have some hardware issues or you've not brought something into an upstate.